Hi everyone, welcome back. Hope you enjoyed lunch. So we've got a lovely afternoon for you here in Jupiter, starting with Jan. So Jan is an independent trainer, consultant, and full-stack developer. He spent the last 12 years building and shipping award-winning video games and high-traffic websites. And today he's here to share his knowledge on testing Angular apps at scale. So let's welcome Jan to the stage. Thank you.
Thank you. Hello. Gosh, there's a lot of you out here. Okay, welcome. Thank you for coming. Today we'll talk about testing Angular applications at scale. We'll focus on design patterns, techniques, and tools that can scale up to support your team despite the ever-increasing complexity of our projects. My name is Jan Molak. I'm an independent consultant working with teams around the world, helping them to deliver better software. As part of my work, I see patterns. I see certain things that work. And what I tend to do with those is I like to share them with the wider community. And what I particularly love about the Angular community is that testing and quality has always been at the very heart of the Angular project. So let me tell you about some tools and some practices that you can use to make your lives just a little bit easier. One of those projects is Serenity.js, an acceptance testing library that helps you write user-centered, automated tests that can scale well despite this increasing complexity. And you can use it together with Protractor, with Mocha, or Cucumber, and you'll find it particularly useful if you're working on large-scale projects in complex business domains. But it's not just the library that I want to share with you today. It's a completely different way of looking at your automated tests, looking at the process, and looking at how we write them. And you might be thinking, but why do we need a new approach? We love our end-to-end tests, right? They're fast, they're easy to write, they're cheap to maintain. They would never fail for wrong reasons, right? Would they? But the best thing about them is that the entire team just loves contributing to the code base. I think I heard a chuckle there. The trouble is that in most cases, none of that is ever true. But should it be this way? So when we start with a new project, typically our end-to-end tests will take us, well, a couple of minutes to run, right? But as the project grows, as the team grows in numbers, we add more test cases to cover all the error scenarios, all the edge cases, and so on. The execution time tends to increase as well. So those minutes will often turn into hours. And as engineers, it's quite natural for us that the first reactions will just throw more hardware at the problem. We'll run those tests in parallel, we'll throw some more browsers. This will sort us out. And while all of this is valuable, and there's been a number of articles and tutorials on the internet describing how to do this efficiently, is this the only thing that we can actually do? So let's look at it slightly bigger picture. Execution time is just one thing, but what about the time it actually takes us to write the tests? So typically, this can take hours, or even days in certain complex domains. What about the time it takes us to analyze the failures, analyze the test reports, and present them in a meaningful format to our business stakeholders? Very often here, this can take hours or days. Now, what about the time it takes us to maintain our code base? Well, here, days can turn into weeks, weeks into months, and our life into misery. Now, this is crazy, but does it have to be this way? You see, in my view, the difference between scalable tests and the world of pain is design. But when we think about automated tests, we hardly ever think about them as production software. We think about them as scripts or something inferior, right? Something where good design practices don't need to apply. Yet over time, as our code base grows, instead of supporting the team, those tests become a burden. They slow us down. And we might sometimes end up in a situation where fixing those flaky tests will take us more time than working on the actual application, on delivering value to the customers. So what goes wrong, and how do we fix that? So let me take you through an example of writing some automated tests for the Journey Planner, a simple yet non-trivial app. And I do promise you there will be no to-do lists in those examples this time. So let's imagine for a minute that the Journey Planner, as you can find it on the Transport for London website, is an Angular application. On the surface, it's just a simple widget. It's just a form, right? A couple of input boxes. So how would we describe the steps involved in testing the following scenario? Let's say we have a commuter, and the commuter wants to travel from Waterloo to Canary Wharf at 9 a.m., and the Journey Planner should tell them that the best option is to take the 8:59 Jubilee Line train. So what would we need to do as a commuter? Well, first, obviously, we would need to open the Journey Planner. Then we would need to choose the station of origin, in our case, Waterloo. And you'll notice that as I enter the letters into the input box, a small list of suggestions appears, right? And you'll notice that Waterloo matches several options on this list. So what I can do next, I can pick the first suggestion from the list. Well, how would I do that as a user? Well, first I would need wait for the suggestions to load. Then I can use my keyboard to press the arrow down, press return, and confirm my selection. And all those steps are involved in choosing the station of origin. Now, I can repeat the same process to choose my destination. So again, I enter the value, I pick the most suitable option from the list, and I move on. Now, choosing the time of departure is slightly more involved, because now I need to click on the change time link, I need to click on the leaving button to indicate that I'm interested in the type of departure rather than arrival. Then I can select the 9 o'clock from the drop-down, and I'm done. I can finally confirm my selection, which means, again, clicking the button and waiting for the results to load. With the results in place, I can finally perform the verification, so I should be able to see the train. But at the high level, those are just 6 things that we need to do as a user. So we've got those 6 business domain-specific, user-centered tasks that we need to perform in order to complete the scenario. And surely, if we are testing the Journey Planner, those tasks will be reused across a number of other scenarios, because they'll be fairly common. So it's important for them to be reusable. So how would we script this test? And you might have noticed that I'm using the term test script as derogatory. So let's start with some testing tools. So if we follow the Angular testing guide on the Angular website, we learn that we should be using Protractor to run and write our end-to-end tests. That end-to-end tests should explore the applications as user experience it. And we'll also promise more stable and faster scenarios if we choose to use Protractor. Sounds awesome. I'm sold. And if you think about it, Protractor is a great tool. It's basically a wrapper around WebDriver that gives us some additional functionality supporting Angular projects. So let's write some beautiful code using Protractor. So typically, the first thing you'll see in a box standard raw Protractor test is a lengthy preamble specifying all the interactive elements that we want to be using in our scenario. And as you can see, even though the scenario is fairly straightforward, there's already quite a few of those elements that we need to be using. But with this out of the way, we can finally open the browser at the website that we're interested in. We can send some keys into the origin field, where send keys is Protractor speak for entering the text into a field. Then we need to wait for a box to appear. We need to specify the timeout. Then we can send some more keys. Then we can copy and paste the same flow and do the same thing for the destination. And hopefully me saying that we have to copy and paste some stuff should already make the alarm bells in your head go off. Then we can change time link click, we can leaving button click, and we can time selector element by CSS containing text option click. So that's what those tests typically look like. They're repetitive, they're boring, and it's very difficult to figure out what they're all about. And to put a cherry on top of that, let's finish with this lovely assertion that verifies that we can see the correct journey. So if we take a step back to admire our wonderful creation, we'll see this. we'll still have those 6 tasks, those 6 important tasks from the point of view of the user, but they're buried somewhere in about 36 lines of noise, of code that's sole purpose is to manage the browser, to manage the state. And if you think about it, very often we blame Protractor for this sorry state of affairs. We blame the tool. But I don't disagree. I don't think it's a trouble with Protractor. It's just how we use it. Now, a very long time ago, Simon Stewart, the creator of WebDriver, has said that if you have WebDriver APIs in your methods, you're doing it wrong. And the very same thing applies to Protractor. A test system, just like any other software system, it needs design. The design needs to be conscious. The system needs abstraction. It needs patterns. And especially if we want the tests to be reusable, if we want them to work on a large scale, on an enterprise scale. But what patterns can we apply? So one of the common approaches to this problem is to use the page objects pattern. And that's the thing that Simon Stewart, again, described in 2009 on the original Selenium wiki. And if you think about it, 2009 was when Angular 1 came out and still had this ugly orange and blue website, right? So that was about that time. So the idea here is that we should represent the structure of our application using an object model. Okay, again, 2009, so how relevant it is to our applications nowadays. So in our case, we could think of at least 2 page objects. We could have one that represents the journey planner, and we could have one that represents journey results. So how would we implement those? Now, a typical page object, such as a journey planner, would have 2 responsibilities. The first responsibility is to describe the structure of interactive elements that we will need to be using in our page object. The second responsibility is to describe the actions that the user will need to perform. So what we can do, we can move those locators from our test script into page objects and define those as private fields in our class. We can do something similar with the low-level interactions. So we can chunk them all up, and we can encapsulate them within methods on the page object. Now, if we're clever about it, we can even give those methods some meaningful names, such as choose origin or choose destination or confirm selection. Now, how does this affect the end result? So instead of specifying all the locators and elements in our test, we start with instantiating a page object. Then we can use it to interact with our page or our widget. So we can navigate to it, we can choose origin, etc. Now, as you remember, confirming the selection leaves us on a different page. So then again, we need to instantiate a new page object that represents the other page, and we can use that to perform the assertion. And it doesn't look too bad on the surface. But what's going on under the hood? So over time, those page objects tend to become fairly large. And the primary contributor to this is the fact that they will define different actions that the user can perform on the page objects, different variations of those actions. Our widgets become more complex, so we add more selectors. Obviously, we can add more page objects to represent the smaller parts of the widget, but then how do we structure that? And the whole thing becomes a little bit of a mess. Not to mention that the page object needs to be kept in sync with the actual widget or page that it represents. The methods on the page objects, they tend to become quite bloated. And if you think about it, a page object is just one step away from the test script I showed you earlier. It's just one level of abstraction. So we still have the same problems, we just swept them under the carpet. And how do we compose page objects? If you think about it, how do we represent an action that spans across several page objects? Where do we put it? Do we create an Uber page object? That makes no sense, right? We could have some helper methods, but yeah, then we have helpers for helpers. So as you might be expecting, that's where Serenity.js enters the stage. And I also tell you a little bit more about the screenplay pattern. So a design approach that a friend of mine, Anton Marcano, came up with several years ago. And the design approach that lies at the heart of Serenity.js. So I'd like to start with the following idea. If an acceptance test is to model how a user interacts with the system, then why don't we make the test itself user-centric? Why do we focus on browsers and the interactions of the browsers, or the structure of the page and how it's built? Why don't we actually focus on the user, their goals, and how they actually perform their journey? So if it's natural for us to think about this scenario in terms of those 6 high-level tasks, why don't we represent them in the code as such? Why don't we introduce a concept of a task to our test domain and make this a basic building block for our test scenarios? So what is a task? In the screenplay pattern, a task is basically a composition of interactions with the system that is performed by an actor to accomplish a certain goal. So this task can be a task to choose origin of a given station or to pay with a default credit card. So we name our tasks in the context of the business domain rather than the implementation domain. So let's look into how we would design such a task, how we would implement it, how much work is actually involved here. Because I'm sure you're already well aware of how much work is involved into designing page objects. So let me show you an alternative. Let's take the task to choose origin of a given station as an example. So what is this thing? This is just a function. It takes the name of the station as a parameter and returns a task. Where does the task come from? So task is a class that comes with Serenity.js. It's one of the built-in classes. So how do we instantiate it? Well, we can say that the task to choose origin of a station is a task where actor selects an origin of a station. That's how you instantiate a task. But how do we actually interact with the system? Well, you already know that in order to select the origin, you need to enter the value of the station into the origin field. And that's exactly the syntax you can use in your tests. And enter is one of the interactions that ships with Serenity.js and basically wraps calls to protractor APIs under the hood. But you're not limited to only those interactions that ship with Serenity.js. You can very easily create your own. So we could have a custom task where we pick the suggestion from a list of suggestions.
Can you speak a little more loudly? I'm trouble picking it up on the mic.
Of course, okay. I'm asked to speak loudly. Fine. Can you guys hear me?
Yes.
Okay? Marvelous. So, picking the first suggestion. As you can see, we can have both domain-specific tasks and lower-level interactions that come with Serenity.js. But who actually performs those tasks? You probably noticed that the word actor came up a lot. So who is an actor in this whole system? So actor basically performs tasks. So actors model the users of our system. Those could be the human users of our systems, but those could be also third-party software systems that interact with ours. So how do we create an actor? Again, we grab the actor class from Serenity.js, and we instantiate the actor, giving them a name. Now, there's a good reason for giving our actors meaningful names. First of all, this helps us to marry up the UX personas with our acceptance tests. So we have a nice link from UX stories and UX profiles, workflows, into our development and testing. But research also shows that giving actor names make us empathize with our users a little bit more. Sounds great, so let's do that. Let's call our actor Connie. Let's say Connie the commuter. What we can do with our actor is we can ask the actor to attempt to perform certain tasks. So Connie can attempt to open the journey planner, choose origin, choose destination, choose time of departure, and confirm selection. Is this a little bit more clear than the previous two examples I showed you earlier? Would you like to know how this works? I love that. So, in order to actually interact with the system, we still need to have protractor somewhere, right? We know that we don't want to have it in our test methods, but it has to be somewhere because that's how we actually interact. And this is where the concept of abilities comes into play. So actors have abilities that enable interactions with the system. What does this mean? You can think of abilities as thin wrappers around clients to a specific interface of your system. So the interface could be the web UI, it could be the mobile UI, it could be the HTTP API or a messaging API. Any external interface that allows third-party actors to interact with your system. And you can very easily create your own custom abilities to match your particular use case. So how does this work with protractor? Well, we grab the protractor object from the protractor package, and we tell the actor to use the ability to browse the web. So in our case, we say that we have an actor named Connie who can browse the web using protractor browser. That's how we inject the actual client into the ability and the ability into the actor. But when you read it, I think you can easily imagine that even non-technical people can easily understand what your test is all about. And the ability to browse the web is what enables those interactions you saw earlier. So the interaction to click, the interaction to enter, the interaction to select a value from a box. But how do we actually perform assertions in this model? If you remember the first assertion I showed you today, it relied on retrieving the text from the page, then performing some transformations, transforming the text into some domain object, and then asserting on that. How would we do this in this model? Here, actors can ask questions about the state of the system, and they can verify the answers. If this sounds like mumbo jumbo, let me show you an example. So we again use the same repeatable pattern to ask the actor to attempt to see if a question matches the assertion. So for example, we can ask the actor to see if the text of the planner header equals planner journey. We can ask them to see if the selected value equals 9 o'clock. But more importantly, we can create our custom domain-specific questions and assertions. So we can say, hey actor, attempt to see if the fastest train departs at 8:59. This is quite a powerful mechanism when it comes to sharing your understanding of a domain through your acceptance tests. So let's have a look at the end result. As you can see, the end result differs quite dramatically from what I've shown you earlier. Each task that we have in our test has an obvious and single responsibility. The intent of the task is crystal clear. With tasks as building blocks, you have tests that are easy to write, that are very easy to compose, that are very cheap to maintain. They're also very easy to share, because each one of those is just a function creating an object. You can package them up into an NPM module, you can share it very easily. You don't have any other external dependencies. Now, Serenity.js is written in TypeScript, and what this means is that when you write an actor attempts to and press Control space in your IntelliJ or in your Visual Studio, the IDE can support you and tell you which tasks are actually available for this actor. So this is very good, especially for teams with varied levels of experience in test automation, because more senior people in the team can prepare those building blocks for the other people who might not necessarily be as interested in this particular subject, but they can still become very productive very, very quickly. Actor attempts to, control space, open journey planner, choose origin, etc. I can assemble those scenarios in minutes. Another thing is that each one of those tasks is unit testable. So if you have any more involved interactions, then you can test those tasks and make sure that they work before you share them with other teams at your company. But what it also means is that if I was to build a widget and share this widget, I can also prepare tasks for it and ship the widget together with the test tasks. So another team can use those tasks to write their tests, their end-to-end test of the entire system. So for example, I can also chunk up, so I can take those tasks and create a higher order one. And then I can take it from here. So I can say, actor attempt to plan a journey from Waterloo to Canary Wharf, departing at 9, and buy a ticket. Then see if you can see a map of the connection, see if you can see the time, etc. So this model leads to a very reusable, very cheap to maintain code. And also, the pattern itself, it's very easy to understand. It's very easy to get. I think you probably already have memorized it, haven't you? And what Serenity.js gives you is a foundation to build upon. So you get the actors, you get the basic classes, and based on those, you can create something that's specific to your domain. But there's one more thing. Having great modeling tools is important. But how do we actually share those test results with others? Not everybody is comfortable with reading the code. And how do we ensure that when the test fails, we actually know which part of the code is affected, which feature, more importantly, which business capability? So Serenity.js can help you with this as well. So what we do is we gather the information that you've added in your tasks, so the descriptions of the tasks, the descriptions of the questions. We capture the information from your Cucumber files or your Mocha files to create those comprehensive reports of your test execution, which can be presented in a HTML format. So you'll see here that every task and every subtask of that task can be reported, together with the execution time, etc. Now, if any of those tasks fail, what you will also see, you will see a breakdown of which task has failed. You'll see a screenshot, optionally if you enable those. You see a screenshot of the state of the system as it was at the time of the failure. And you also see which feature of the system is affected. And if you think about it, this is quite a powerful mechanism. I mean, if you tell your product owner, well, we've got 5% tests failing in our test run. Well, this information is great, but, well, useless. Which 5%? What is affected? If I can just point them to a report showing them that, hey, we've got 2 tests failing and it looks like the checkout is broken, that's actually quite important, right? And this can lead to a very quick business decision. Should we go live with this? God, no. But the information about the percentage? Meh. Whatever. Yeah, we'd probably leave that. 95% is green, so it's great. So what I would like you to do next is to take your phones and take a picture of the next slide. And I'll try to get out of the picture. Take those questions together with you to your office and have a look at your code base. Have a look at your end-to-end tests. And try to think, how much time do I actually spend maintaining the tests? And it's not just now updating them. How much time do I spend now fixing the flaky ones? How many times a day do I need to go back to them? How many times do I actually complain about those? Am I modeling my users' interactions with the system, or how the system is built? What am I doing with those tests? And is it the right thing to do? And can I share elements of my test framework with others? Is it easy? Would they actually want to do it? Would they like to use it? And how much duplication and dead code is there in my tests? And do I know? And what about finding the issue when a test fails? What about the amount of time it takes me to update the test when the system changes? And more importantly, can I use my current test suite to drive the design of the system, in a proper TDD fashion? Does it allow me to do it? And more importantly, is the right time to find a better approach? So the thought I would like to leave you with is that throwing more hardware and more browsers at the problem will definitely improve some things. But are those the most important things to improve? So design of your tests affects their scalability. Try to make your tests scalable by design. Thank you so much.
Thank you. All right, it is room-changing time. Up next in this room, we have a talk from Connie Wan and Jen Burry about migrating a over 1 million line of code project from AngularJS to Angular. In Saturn, managing your huge code base like a boss with Jeff Welpley. Right, we're going to get started. If everybody grab a seat, sit down, settle down. We're going to get started. All right, it's my delight to introduce our next speakers. So software engineers Jen Burry and Connie Wan drive Angular adoption for the Google Cloud platform inside Google. At Google since 2012, Jen introduced AngularJS and today is the overall tech lead for Angular client infrastructure development across Google Cloud platform. Connie directs common component development and is the tech lead for the team of engineers that builds all of the common components that we use in Google Cloud. Together, they have a wealth of expertise using Angular hands-on inside one of Google's largest internal Angular projects. Connie, Jen, welcome.
Thanks. Okay, so today we'll be talking about how a real Google project is migrating a very large code base from AngularJS to Angular. We'll tell you about some of the strategies decisions we've made along the way and how we think about migration. We'll also cover real code that shares the technical details of how we're implementing these strategies. And we'll also talk about some of the lessons we've learned along the way. So I'm Jen Burry. I'm the TL for client infrastructure on Google Cloud.
I'm Connie. I'm the TL for UI components.
So our product is the unified web console for the Google Cloud platform. And that includes things like dashboards and overviews, screens for interacting with and configuring cloud resources, and also some more complex and interactive UIs, things like logging and monitoring and code editing. Our project is currently using AngularJS. So as of the beginning of the year, we are on AngularJS 1.4. We're on 1.5 now. We have historically also used Clojure JavaScript, which is an annotation-based type checking library. We also use Clojure GSS, which is a CSS library, and we have a set of pre-material UI components. Our project is also huge. We currently have over 700,000 lines of source code, excluding comments and whitespace, and another 700,000 lines of unit tests. So this is all content that would need to be rewritten for us to move to Angular. We also have hundreds of reusable components and services. And in addition to all of that code size, we have a lot of organizational complexity. So we work with dozens of contributing teams across multiple offices and time zones. And we also release twice a week. So we have to keep things completely working at all times. And then on top of all of that, we're still growing, and quite quickly. So in addition to the obvious challenge of migrating a very large code base, we also need to support launch velocity and developer velocity. Nobody's going to be very happy if we tell them that we just can't ship any cloud features for months and months while we rewrite our whole code base. In addition to that, of course, our developers don't really want to have to simultaneously maintain all of their new features in both Angular and AngularJS while we do this migration. And since we have a lot of shared services, that also puts us at risk for having teams blocked on each other as we have a lot of interdependencies. So how are we actually going to approach this migration? Our solution was to break up our UI into multiple independent migrations so that people could migrate in parallel on their own timelines. So starting with our AngularJS app, we have the portion of our page that corresponds to the ng view. So that's the part that changes as you navigate across paths. And then outside of that, we have a number of more static UI widgets. So things like login and logout, navigation, preferences, all that sort of thing. We knew that we wanted to allow features to migrate on their own. And we also wanted to give them control over how much they migrated at a time. So we settled on a page-by-page strategy, since that would allow teams to just migrate a single page at a time if they wanted, or migrate a whole set of pages and launch those. In addition to migrating on page by page, we also wanted to be able to migrate those UI shell widgets in parallel. So different sections of our UI shell can be migrated separately, and that can happen at the same time as our product page migration. One benefit to this approach is that as our UI shell is migrated, even pages that are still on AngularJS benefit from improved load times because more of our core page is moving to Angular. As we move on, the base page stays AngularJS until the very end, and then our last step is to clean up the core services and remove all of our bootstrapping, and at that point, we can just delete AngularJS.
Okay, so let's see how this is reflected in our code structure. So here is our pre-migration code structure. The most important thing to note here is the distinction that we call core versus product. So core is the horizontal stacks that you see here that are all interdependent and build on top of each other. Whereas our product UIs are largely vertical slices that are independent from each other and that write their own business logic. So for our migration, we want to do this in stages starting from the bottom of this diagram and moving up. So the first stage is interop, and this is just getting an Angular app working alongside an AngularJS app. And the key pieces of this are what you would think with Bootstrap and routing. After that, we can do what we call our core migration, which is to migrate our core services or use ng-upgrade, and to migrate our UI library. And we'll talk about each of these pieces separately. After that, you have the stage set for product migration. So each product will be able to migrate independently as much as possible, and we want this to be flexible and decoupled if we can. Part of that also means that as products migrate, they can clean up right away. So the first stage of cleanup, which is the next phase, is products deleting as they go. So once you're fully launched in Angular, you can go ahead and delete your AngularJS code. At the same time, as part of the core cleanup, we want to fully migrate all of our core services so that we have a clean separation between AngularJS and Angular. Once we have that and all of the product dependencies on core are gone, that's when we can delete all of core for AngularJS. And of course, the last thing to go is our base page bootstrap, which will be there in AngularJS throughout the entire migration. But once everything is gone, we'll be fully an Angular app.
OK, so we've laid out this great strategy. But how are we actually going to accomplish this? Well, the first step is bootstrapping. So we need to just get Angular and AngularJS running side by side on the same page. So originally, we were using upgrade module. But in conversations with the Angular core team, they actually gave us another option called ng-upgrade lite. You might have heard of this, but essentially, this allows you to separate out AngularJS digest cycles and Angular change detection into two separate zones. And for us, this was really important because we care a lot about performance. And this is how we got to have really great performance with our setup. This was also a very good match for us because we're not making super heavy use of ng-upgrade. So we're essentially upgrading services and then downgrading a limited number of components. So this is working great at this point. And one of the other benefits of ng-upgrade lite is it's actually much easier to bootstrap. So we have our AngularJS application, one application module, and then we have an Angular application module. We use downgrade module to downgrade that root Angular application module, and then we add that to the module dependency array and feed that to Bootstrap for AngularJS. And that's it. We actually have Angular and AngularJS running side by side in our application at this point. But of course, we need to figure out how to actually include this in the page, right? So it's not enough to just have them running side by side. We need an Angular component to actually show up inside of our AngularJS app. And this is where downgrade component comes in. So as an example, we want to be able to include the Angular router outlet in the page. So this is a just very simple component. It just wraps router outlet, and then we define a new ng module for this component. And the important piece here is that this new component gets added to the entry components array. After that, we can just call downgrade component on our Angular component. That outputs an AngularJS directive. And then we can just include that AngularJS directive directly in our AngularJS base page. There was nothing magical about the router root in this last example. So this can be extended to other UI widgets. So if we want to be able to rewrite, say, our login button in Angular, we can use the same approach. OK, so up until now, I've just sort of showed this ngView router outlet thing. How do we actually get routing working in Angular and AngularJS at the same time? So this was actually very important for us. Some of the initial conversations we had revolved around things like, well, maybe we can have like a page wrapper that downgrades a whole page, except we actually are really excited about the new Angular router. It offers things like can activate guards and child router outlets, and we want to be able to make use of all that. So we actually want to use the Angular router directly. So to do this, we're actually running both routers at the same time. So sort of similar to how we're bootstrapping both applications, we set up both routers. And we actually have both routers seeing and handling every single path in our application, regardless of which system kind of owns that path. But we make sure that only one of the systems gets to actually render content. This is also useful because it means that both routers always have a state, and they can always see the current path. So this can help out with some of those NG upgraded services as well. So in this view, we have an NG view and a router outlet side by side. And then depending on which framework we think is active, we actually show and hide these. So when we think we're showing an AngularJS page, we hide the router outlet, and AngularJS takes over and renders content, and then vice versa for Angular. We need a little bit of glue code to make this work. So there's a location synchronizer that allows Angular to actually know when AngularJS has updated the route. There's one of these in core already. It needs a little bit of tweaking to work with NG Upgrade Lite. So if you're interested in following that as we get that back into the core code base, that's the GitHub issue to watch. To ensure mutual exclusivity, we have a small array of path prefixes and regexes, and then we just have a little function that for any given path can return whether the path is registered to Angular or AngularJS. And then we use that in both of the routers. So on the AngularJS side, we use an otherwise block to map that to a single controller. And then the controller checks whether this is an AngularJS or Angular path. And if it's Angular, it just doesn't render any content at all. And if it's AngularJS, it renders a 404 page because the system believes that this path is supposed to be controlled by AngularJS, but we couldn't find a route mapping for it. On the Angular side, we have a little more powerful APIs. So we can use the matcher to be able to map this to a function. So this configuration here says, after we go through all of the main registrations, if it matches an AngularJS registration, just render this component that has no content. And then if it falls all the way through to the bottom to that wildcard route, then we render the Angular version of the 404 page. So at the end of all this, here's what we end up with. So our request comes in. It's handled by both the AngularJS and Angular routers. And then from there, it branches out to either render content, render no content, or render a 404 experience. I'd mentioned before that we're not using NG Upgrade very heavily, and I wanted to talk about a couple of the reasons why. So just as an aside, we weren't really planning to upgrade components to begin with. We're using a new UI library, so we didn't really think that it would be a great user experience to mix Angular and AngularJS components in the same page because some of them are material and some of them aren't. But there's some technical limitations as well. So if you have complex AngularJS components that use the $ compile service, those aren't going to work with Upgrade. So we were mostly focused on services. And as we started to write code, we found that sometimes writing code with upgraded services sort of force AngularJS patterns into Angular. And so at this point, we're avoiding using NG Upgrade with a lot of our common services, but we're focusing on using it to decouple migrations. So this has been an absolute lifesaver for us, and it is working really well for this purpose. So imagine that feature A depends on a common service from feature B, and the feature B team hasn't started their migration yet. This allows them to not be blocked, and the first product team can move ahead. Here's an example at the top of some code that's using an NG upgraded service from AngularJS. This is using the $resource service. So we have a DAO, we call get, and then we have to call $promise, and then we get this whole promise chain. And this isn't really actually what we expected our Angular code to look like. Down at the bottom, that's code that's using a native Angular service. It uses observables. We can use observable operators. And this is kind of a little more where we want to get to. So as a result of that, we're not using we're not using NG Upgrade for all of our common services. There are also some potential hurdles if your services do things like access the root scope or broadcast events that can make NG Upgrade a little bit tricky. And we also found some test friction as well. So if you use an NG upgraded service, you need to add that to the super providers list. And if you forget to do that, the error can sometimes be a little bit inscrutable.
All right. So let's take a look at a last piece of interop that can be unexpectedly complex. So this is styling, also called Connie Complains About CSS. So as part of our migration, we decided to change design languages. So we went from the classic Google Kennedy design language, think Gmail, to material design in Angular. And not all projects will be doing something like this, but it definitely exaggerated the problems that we ran into with CSS. So we have a lot to talk about. So the challenges we came here with are scoping CSS to regions of the page and layering CSS from multiple sources. So let's talk about each of those. So with scoping CSS, the problem is that CSS is very global, but we really want to be able to decouple different parts of the page in their migration. So any particular part of the page could be in either framework, and it could be in either design language. So the tools we use to address this are pretty standard: container classes, naming conventions, Angular view encapsulation, and we'll talk about each of this in the context of a diagram. So here's the ideal of what we want in our UI. All of the UI shell, including the top bar and the left nav, is going to be in Material regardless of which framework it's in, AngularJS or Angular. Whereas the page itself, if it's in AngularJS, it's going to be in Kennedy, and if it's in Angular, it's going to be in Material. So the way we did this is by drawing all over our diagrams with boundaries. So on the boundary between AngularJS and Angular, and between Material and Kennedy, we have prefixed naming. So as a familiar example, AngularJS Material uses the MD prefix on all of their class names, whereas Angular Material uses mat as their prefix, and this is one of the reasons. In addition, for all of our Angular pieces, we further encapsulated them using either a class on some top-level container in the DOM, or we relied on Angular's view encapsulation for components. And this extra layer of encapsulation was for both stability and for layering. So let's talk about layering. Why do we need to layer? Well, it's because we have a million sources of CSS. So we've got our own Kennedy styles, our own material styles. As I already mentioned, we're also using AngularJS Material and Angular Material. And for each of these sources, they're split into what I'm terming the background and the foreground styling. So the background is theming and reset and HTML defaults and things that apply pretty globally. Whereas the foreground comes with UI components and is also used to override other pieces of styling that you might not like. So the good news is that CSS comes with layering tools. Cascade order is within its name, and specificity is another tool you can use to override other pieces. But the problem is, with Angular's AOT compilation, you get unpredictable binary ordering of your CSS, especially for the foreground. You don't really know what order it's actually going to be in your header. So while we would like to have a nice, neat cascade order here, where you have the background elements first and the foreground elements after, and you place your own foreground above the external foreground so that you can override it, it doesn't really work that way, and it's not really that nice. So in reality, we do something a little bit more like this, where we rely on specificity and extra layers of encapsulation to make sure that our foreground comes after the material foreground, Angular material foreground, in terms of style ordering. Short disclaimer, this is actually a lot more complicated in reality, but that's a rant for another time. So we've got interop working. What do we do now? So we move on to our core migration. If you remember, we did our migration in various stages, the first one being interop and just getting things working side by side, but the next one being core migration. So this is migrating core services, migrating the UI library, and creating migration tooling. So we already talked about core services in terms of ng upgrade, so let's focus on the UI library. So what is the UI library? So going back to our old diagram, the UI library sits in between core and products, and so it's the piece in between that helps to glue them together. So let's unpack this a little bit into a scary-looking diagram that I will explain. So you've got product UI, which is built on its own business logic and has its own tests, and all of these pieces plug into UI components. Both those UI components and the things that plug into it are what we're calling our UI library. So the biggest part of it is our UI components. These are some visual examples of them. They are reusable components in our UI. They are Angular components, and they extend Angular material, which we are using heavily. They're mostly stateless, mostly content agnostic. Basically, they accept most things through projection. In addition to the UI components, our library is also composed of a bunch of plugins, things that you use to interact with components. And this can extend all the way from working with templates to working with the TypeScript to working with testing. All of these things, any number of these things can be applied. And it's all nice to have. It's icing on the cake. So why invest in this? Why have such a heavy UI library that is so extensive? Well, there's a lot of generic reasons to want this. There's a reason why Angular material exists. I would encourage looking at that and looking into how a UI library can help. But the thing we're focused on here is migration. And the biggest thing this gives us is that it reduces the time and effort of product migration. And one key factor in this is that the more extensive your UI library is, the easier it is to write migration tooling because your code gets more consistent and you can map things better from AngularJS to Angular. So let's talk about that migration tooling. Again, there's many types of tooling you can write. My first disclaimer is that you're probably not going to be able to tool away your entire migration. It's not just going to magically do it for you, but it will do parts of it. So we've explored almost all of these types of tooling, but the one I want to focus on here that's most relevant to the UI library is translating template syntax from AngularJS to Angular. So this is best shown by just a short example, but first, let me just go back to this diagram. Our template migration tooling is focused on this part of the interaction, where you have the product UI interacting through templates with UI components. And a transformation looks something like this. So this is an example using AngularJS material and Angular material, where we have a select component that maps one-to-one in both libraries. And the transformation you're making is both with the syntax of the template and with the actual component pieces and the subcomponents and everything that goes into it. And again, why invest in all of this tooling? Why continue to grow core at this point? The biggest thing is that migration burden can be passed from products to core. The bigger your core migration is, the smaller your product migrations are going to be. And the smaller the product migrations are, the less time they take, the more independent they can be. And it turns out product teams like this. And so having a good, strong UI library and tooling is a big way to sell and motivate product migration. All right, so speaking of product migration, what's next? Well, what's next is we're running out of time this talk. But what it really is we have kind of caught up to our story up to this point. So where we are at is we have interop functional. Our UI is functioning fine side by side. And our core migration is largely complete. We're feature complete. We've started some experimental migration, and actually we're well into, we have a pilot launched, and we have teams looking at moving more and more of their code base. And there's a lot more to explore, right? There's a lot more product migration to do, and there's a lot more to learn, and we haven't even thought about cleanup yet. But there's also a lot that we've already learned, so let's focus on that. All right, what went well? Well, better technologies, for one. Angular really is great. All of the talks you've heard about unicorns and rainbows and happiness are true. TypeScript in particular is really great and good to work with, and all of this has contributed to a lot of great developer productivity improvements. So that, I think, would be the biggest thing. The other thing is we've had a great collaboration with the Angular core team to work through things. In a lot of ways, we were their guinea pigs, and they were very kind to us. And we have really gotten their help on a lot of things to get interop working. Some of the things we wish we had known going in. So we glossed over this piece because it wasn't really super relevant, but we had a lot of trouble integrating with our internal build systems. And this is possibly also going to show up if you have your own internal build systems. Another thing we wish we had known is also the trade-offs that come with ng upgrade. As Jen mentioned, we did go in initially thinking we were going to use it pretty heavily, and then we ended up pulling back from that. And another more organizational thing is that when you're doing a large migration of your code base anyway, there is a temptation to say, well, why don't we just lump this other migration in with it? And that times 25, and suddenly you have a super unmanageable and crazy migration that's really hard to manage. So that's something to watch out for. And then lastly, we did run into a lot of framework level blockers as a large project who's kind of working with the Angular core team very closely for some of the first times. But hopefully we've ironed out a lot of this for you, and it'll be a lot easier the second time around. So as some final thoughts, there will be trade-offs and decisions to be made during migration. Having clear goals and priorities will help, but there are a lot of people with a lot of different priorities. There will still be some unknown hurdles. Hopefully we have ironed out some of them for you. But there will also be continual and measurable progress. So with that, good luck, and thanks.
Thank you, Connie. Thank you, Jen. All right, up next in this room, Rado Kirov will be just talking on building Angular applications like Google. And over the way in Saturn, real-time Angular apps with GraphQL with Uri and Camille.
Hi everyone, welcome back. So up next we have Rado. Rado's been on the Angular core team since the summer of 2014. For Angular, he worked on the AdSense serving stack, responsible for serving billions of ads daily. And today he's going to talk about building Angular applications like Google. Rado, please come to the stage.
Hello everybody. Thanks for coming to the last talk of the conference. My name is Rado. I work at Google. Work on the Angular team and on the team that supports the TypeScript infrastructure in Google. That's my Twitter handle, and I'll be talking about building Angular applications like Google. Google is known for scale, so there will be a lot of talk about scaling up. Everything you see here is part of Angular Labs umbrella project. So some things are kind of experimental. We want you guys to take a look at them, be excited about them. If you want to use them in your production systems, probably not the right time right now. We'll see. OK, so we're all web developers here. So are you familiar with this question? Does it happen to you? You go to your users and you ask them, do you want a very powerful application, kind of like a desktop application with lots of features, lots of power, or you want this easy-to-use application like the web? You just type the address in the URL bar, and very easy to use. So if you go to users and you ask them what's going to happen, yeah, exactly. Kim Kardashian agrees with you. Not really, it's fake. But they will tell you, why are you asking me such a stupid question? I want them both. Get out of here. So let's flip it around. We provide tools for you guys, and we come and ask you, do you want new JavaScript features? Async await, TypeScript, type checking. Do you want all that, or do you want that instant edit refresh cycle? What do you want? Well, you want both. Exactly. So let's figure out how to deliver that. So we want both, but this is what we see in the wild. We see that things start well. You feel like you have it both, right? At one end, code base is small. You set up your tooling. It looks great. Instant edit refresh cycle. Application starts to grow, and things that you didn't even think about before are starting to weigh you down. You're like, development sucks, and you're almost not sure why, but it's kind of like the tooling. You blame the tooling. That's what we see that happens if you're not careful. This is where we want to be. Like, we want, as your application scales, we increase the lines of code. We want to see you still have enjoyment building this application. We want it to be, it's going to increase, but we want the slope to be small. We want it to be gradual increase. One main thing to do as we're scaling up is we got to know when to complain. If we complain too often, nobody's going to listen to us. If we don't complain at all, maybe we really set up our tooling bad. We did the wrong setup, and something really should be complained about. So you have to know what too slow means. And to that end, what we've decided to shoot for, or target at, is 2 seconds edit refresh cycle. So this is what we're trying to achieve. We think we can do it. And I'll show you some of the tooling we use to try to achieve this, but 2 seconds, we think it's reasonable for even very large applications. And how do we know about large applications? Because we work in Google, and we do have lots of TypeScript code and lots of Angular code. We just heard from Jen about Google Cloud Console, which is a single application with 10,000 TypeScript files, and around 3,000 of them are Angular. That all of them go into one application, to one front end. And in total, we have a bunch more, but they're split amongst smaller applications. So given this scale, we think we can achieve the 2 second edit refresh cycle. And now you're asking, how do you do it? And can I do it too? And that's what I'm here to answer. All right, so how do we do it? A simple concept, incrementality. So we really have to use incrementality. What do we mean by incrementality? The size, so you make a change, the time to rebuild a project should be comparable to the size of the change you made, not of the rest of the project. Any project, no matter how large it is, you're still making small changes, one file at a time. You're still making the change. One edit at a time, you open a file, you change the file. You don't want the rest of the size of the project to weigh you down and make your builds really slow. So to achieve that, you have to use incrementality. OK, let's do this. Let's start thinking about incrementality. We need some boundaries, like what is the unit of incrementality? So here's what TypeScript gives us: function, classes, modules. Files are basically TypeScript, ES6. Every file is a module. Turns out neither of them is really the right unit. We need something a little bit bigger, and TypeScript doesn't have that unit. We have to define our own packages. Right? So we need to define something a little bit bigger that contains more than one file. So we define TypeScript packages. Each package gets compiled separately. So the TypeScript compiler will execute on each package. All the dependent packages will just receive the .ts files, which describe the type shape of the package, so it can type check against it, and it doesn't need to see the actual sources. So we have packages as units of compilation, and that helps with incrementality. What do we do with Angular? Turns out Angular has this, we had this from the get-go. It's ng modules is the actual unit of incremental builds for Angular. So Angular also has an ngC compiler. Instead of .ts files, we have these ngSummary JSON files that serve the same purpose. They describe the API shape for other packages. And yeah, that's one of the main reasons why we have ng modules. So I know some of you, if you're working a smaller project, you're like, ng modules feels like this extra thing. Why do I need it? Well, they're actually the bread and butter of really big projects. When the scale grows, these are the packages they'll define the packages of your Angular application. So at this point, if you're thinking packages, all that means like, new GitHub repo, versioning, releasing, like heavy overhead. That's not what I'm talking about. I'm talking about very thin, easy to create, easy to reuse packages. In Google, we have a monorepo. They all live in the same repository, so we don't have any release step as we're changing packages. They're just these units that help our build. So on average, I have around 8 TypeScript files per package in Google. I'm not saying those are preferred numbers. This is just what actually has evolved. Around 1.5 components per ng module. It's pretty low, but that's what the developers are doing. All right, now that you have packages, what do you do? How do you stay fast? Now you just have to follow 3 simple rules. You need to rebuild at the right time. So rebuild the right packages at every single time. No complex work done over all the sources, and keep your build tooling warm. So let's step through each one of those things. What are the right packages? When you change a file, well, we're going to rebuild the package that contains that file. We have to do that. And then there's the extra step, which is, well, has the API changed? If the API has changed, we have to rebuild all the dependent packages. If the API hasn't changed, we're done, right? So we have to do this calculation. Here's the example. So if I work on one of the modules, work on module 0, if it has the same API, I don't need to rebuild any of the other packages that depend on it. I just need to rebuild that one down here. So I'm making changes. I just keep rebuilding this one. If module 0 has a different API, I rebuild that. Then I have to rebuild the parent, because maybe the parent uses some of the methods on this package, but I don't need to touch the parent's parent. There's another scenario, which is if team 0 re-exports the API, then we have to continue this chain, and so on. But rest be assured, the rest of the build graph doesn't need to be rebuilt. So here's an example what I mean by API change. Here's a component. This is how it looks right now. I come and make this change. I'm just going to add one more logging line in the implementation of the click handler. The API, as defined by the .ts file produced by TypeScript, hasn't changed in both cases. It's exactly the same. Therefore, the parent doesn't need to be rebuilt. The API is always just one method. It returns void. Here's another change. This is a change where I add another click handler. The API now looks a little bit different. There's an extra method. So now I need to rebuild the parent. All right, so that's kind of the reasoning you have to do every time you make changes to achieve incrementality. It's kind of, it's not so fun to do by hand. We just did it on the stage, but obviously we need a tool to do this reasoning for us, right? Maybe there'll be one at the end of the talk that does that, foreshadowing. All right, number 2, no complex work over all the sources. So TypeScript and NGC, they can work incrementally. Our build process usually is more complicated than that. We have more tooling than that, right? We have CSS preprocessors, we have minification tools. There's more, like the real world is more complicated than just these 2 tools. So you're probably going to do some work over all the sources. And my only advice is don't do the complex work, right? So when you do some work over the whole project, be very cognizant of that, measure it, and don't do anything complicated there. Here's an example what we have to do in our setup. So this is the kind of the build part. The cloud is what I just showed you. This is where TypeScript works. At the end of the day, there's a dev server that has to concatenate the sources and put them on the browser. That concatenation, that's actually work that needs to be done, but we think it's kind of trivial. We can measure it. We know it's fast. That's OK. If you have a slow global optimizer, like Clojure compiler, what we use in Google, that's something that doesn't have right now a good incrementality story. It's, we just don't run it during development mode. We kicked it out of the development flow because it doesn't achieve the incrementality. Therefore, you cannot reach your 2-second SLO. And finally, this is a very straightforward trick in this business. Keep your build tools warm. If you're calling Node.js with TypeScript compiler, so TypeScript compiler itself is a Node.js program. It's turns out it's around 1.5 megabytes of JavaScript. If Node is reparsing 1.5 megabytes of JavaScript, that's not efficient. You got to keep it parsed and ready, cache the right things, and use all the CPUs you have ready on your machine. Right? All right, so what is a tool that achieves all this? That is Bazel. That is a tool that we've been using internally in Google for many, many years, like at least 10 years, and only recently has been open sourced. You can learn more about it at this really cool new top-level domain name, .build. It's a real URL. This is its tagline, fast and correct, choose to. Remember that trade-off? You really don't want to make a trade-off. Another trade-off you really don't want to make between fast and correct. You really want to be fast and correct. Bazel really tries to achieve that. It's a general-purpose build tool. It is used for all Google builds for all the languages, right? So even for Java, C++, languages that have other build tooling, we use Bazel for all of them. It is also agnostic to your version control system. It's not really tied to Git, Mercurial, or anything that we use. And why is it fast? Well, yeah, it does the 3 things I just mentioned. Therefore, that's how it achieves the speeds at the scale that we use it at. We've done some benchmarking. This is the URL where you can see the benchmarking, and it appears to be doing a lot better than the current state of the art, which I guess is Webpack. But disclaimer, don't trust benchmarks. What we're really more excited about is the trend line, which is, so we're going into the thousands of TypeScript sources, and it's scaling pretty nicely, like what appears to be almost linear curve. We're still very far from the SLO. The SLO is the green line here. So we have work to do. And again, the lines are always going to cross, but we're hoping to push it further than the size of the applications that big enterprises are writing. So some other benefits for Bazel. It is one build tool for front-end and back-end. Like I said, we use it for all the languages. That has some great benefits when you, for example, go and edit the data exchange format between your front-end and back-end, and automatically your build tool would rerun all the tests for both sides of the story. It's very nice, and it makes you very productive when you have that available. And it really tries to achieve hermeticity, which is a fancy word for saying whatever happens on my machine, probably the same thing will happen on your coworker's machine. So your builds are reproducible. That's a great thing to achieve, just like having your tests reproducible. This probably has happened to many of you when you pass a project to your coworker and it doesn't build, and you tell them to remove node modules or something. Yeah, that's something that's, with the right care in the build system, you can avoid. And of course, if you can reproduce it across different developers' machines. You can reproduce it in the cloud, and you get a bunch of other benefits from that. All right, do you guys want to see it in action, actually? Yeah, enough talking about it. How does this look like? All right, so here I am. So this is an enterprise application, very large enterprise application. This is my first day on the job. So I'm told I'm working on component 0. Component 0 is part of module 0, ng module 0. There are 10 components in this module. There are 10 modules in this team. And this team, there are 10 teams, and they all work on this airplane application. There's one application that rolls all this up. So if you did the math, that means there are 1,000 components, different component types, right? 1,000 components in this application. Not very well named components. I don't suggest you name your components like this. Almost feels like a script wrote this application. I don't know why. All right, but it's my first day. I don't know what to do. How do I even build it? Well, I've been told it uses Bazel, so that's nice, because Bazel has a query language that I can just start querying the whole build and see what's happening. So let's first see how many ng modules are there in this application. All right, wow, lots of ng modules. If I see, okay, 200 ng modules. Like I said, every ng module is its own build unit, and the components are not seen here because each module contains 10 components. How do I start it? Well, I know that there's something called Node.js binary, and whatever the web server is, it has to be a Node.js binary. And I query it quickly, and I see there's only one Node.js binary. So that's probably the thing I need to run. So let's do Bazel build. And I will profile this into a file so we can take a look at a bunch of statistics about the build. All right, so I'm kicking off the build in a clean state. There's nothing cached right now, so there's some time. It's gonna take some time to build 1,000 components. One thing you see immediately, it's a little bit low here, but there are 3 workers happening at the same time. That's because this machine has 4 cores. One is taken by Bazel, the other 3 are immediately parallelized by the build. So it is building. This is a pretty old MacBook, so it'll take a while. While it's doing that, I want to show you the actual file that describes this build. Let's make it a little bit bigger. So this is the description of the build that I'm passing to Bazel. For those of you that are a little bit older in the audience, you remember make, and all of this is starting to sound like make. Good news, the syntax of Bazel is sane. There's no significant tabs. This is Python-inspired syntax, although it doesn't have significant white space. Pretty readable right away. There's some visibility at the top. I import an ng module, then I say this is my module. It takes some files, and this is my tsconfig. And there's some tests. All right, let's see if this finished. All right, it did finish. It took 1 minute to build the whole application. I can look at the analyze profile. Analyze. All right, so there's a lot of information that it captured. What we really care about is I guess total time, 1 minute. There's the information here that we can poke around if we get more interested. The number of actions, this is the number of compilations that happened. I guess divided by 2, there's action to move file. So it's around 100 compilations that happened. That matches the fact that we have 100 ng modules and 1,000 components. All right, that was not very fast, but it's a big application. Let's now see the incrementality aspect of it. So what I'll do next is I run iBazel, which is the watch mode for Bazel. So now it sets up watch on the 1,000 files. So whenever any one of them has changed, it will recompile. And there it is. And I start the server. It didn't take 1 minute because all the actions are cached on disk, right? Even though I killed the Bazel and restarted it, everything is cached. And now we can take a look at this amazing airplane application. Don't get your hopes high. It's not very pretty. But anyways, there are all the components. Each one of them has its own component with its own AOT compilation and all that happened. And I can, as a true enterprise application, I'm leveraging impact to deliver value. Yes. That's great. So I'm told I should deliver more value, though. This is my task. This is my Jira ticket. So OK, let's deliver more value. And what happens? I didn't touch anything. It automatically rebuilt and refreshed. And this took a lot less than 1 minute. I hope you, you believe that. In fact, it took 1.6 seconds, less than our SLO. Yeah. How do we do it? No magic tricks, incrementality. We just rebuilt whatever needed to be rebuilt. Everything else was reused. 2 actions taken. Like I said, there's 2-to-1 factor. There was 1 compilation that needed to happen, and that resulted in 2 actions. And this was because the API didn't change. Remember what I was talking about earlier? I only changed the implementation. I didn't change the API. So let's do one other change where we'll kind of change the API. So instead of leveraging impact, let's do something more drastic. Let's do a paradigm shift. Paradigm shift. And we'll just add 1 more handler here. And we will double the value. And again, I just save it. And there it is. All right. Yay. I think I'm climbing the corporate ladder. And like I said, the API changed, so we had to do 4 actions right here, which meant 2 recompilations because we recompiled the component and its parent component. And it took a little bit more time, 4 seconds, but again, very far cry from the 1 minute it took initially. And that is the end of my demo. But again, I just want to point out that there was no, this was a big application. We made incremental changes, and everything needed to be type checked was type checked. So I didn't push down any work on some integration engineer or somebody down the pipeline that had to resolve my changes. This whole application, as big as it is still completely TypeScript correct. Like it's correct as defined by TypeScript, right? So all the type checking needed to happen has happened. So there were no tricks to play or like asynchronous type checking. So like the type checking happened synchronously. Only when we were ready, we pushed it to the screen. So there were no tricks. All right, that was the demo. We used pretty weak machine with 3 workers. Turns out this demo actually, because it has a branching factor of 10, if you run it on a desktop, as you see here, it uses all the CPUs, right? It keeps scaling as much as your build graph, as much as parallelism you have in your build graph. What happens when you have even more parallelism in your build graph that your machines can have? Well, you can build it in the cloud. That's what we do internally in Google. There's a project to run your own build farm with Bazel. And actually, I think just recently, it's been announced in the Bazel conference. I think it's happening concurrently with this conference. But recently, we're announcing that you can also build in the cloud, on Google Cloud. I don't have the link yet, but you can see how naturally, when you have this hermeticity, you can just ship your builds to the cloud and scale basically as much as you want. All right, that's all I had for the Bazel demo. You can find it here at this. You can find a demo and run it. There's nothing secret about, like it doesn't use anything that's not available. The feature as part of your Angular build is still a little bit experimental, therefore the Angular Labs. What we're working on right now, a bunch of polishes, Windows support, karma testing, more benchmarking. We want to change the actual Angular build on Angular/Angular. Angular is quite big as a TypeScript application itself. We want to change it to use Bazel. What we're working on maybe next year, basically, down the road, code splitting is something that we didn't use in this demo at all. Closure compiler is the optimization, the JavaScript minification tool we use in Google. It already works with Angular. It has a few rough edges that we want to improve on, and that's something that's on our roadmap to improve on. The build file that you saw, it didn't look too terrible, but we can auto-generate those based on your TypeScript imports. So we have some tooling in the pipeline to do that. And finally, expose it as kind of an experimental option as a CLI, so you guys can bootstrap with it and start using it faster if you wish to do so. If you're very excited about this, if this is like, I've been waiting to hear about this, I work on a big enterprise application, I want to start using it, you want to be part of our pilot launch, please email our DevRel, or also just talk to them, they're here, so Rob and Steven, talk to them. The Narwhal team is also here, and they're also looking into using Bazel, and reach out, and we can collaborate on using this tooling. Want to learn more? Follow Alex Eagle. He's kind of the driving force behind all this. He'll be giving this talk if he was here. I'm giving instead of him. Follow him on Twitter to get updates. This is the canonical link, not just for this talk, but for all the talks and documentation around this project. ABC, standing for Angular, Bazel, and Closure. Bazel and Closure being the kind of the internal Google tooling that we're exposing externally for you guys to use. And that's all I had. So thank you.
Thank you, Rado. So we're going to take a short break now, and up next, back in this room, will be the Angular team Q&A. Make sure you submit your questions on Twitter with the hashtag AC17panel. Thanks very much. So welcome back, everyone. So up now we have the Angular team. Say hi, everyone.
Hi, everyone.
Well done. And they're here ready for your questions, which you've been tweeting. Thanks very much. So I'm going to start with one. I actually didn't realize how good the Angular team are at animal noises, which I discovered during a panel session this week, last couple of days. So it's not good. It's going to take too long going round. So we're just going to go 1, 2, 3, and all of you have to do your best animal noise at one go. Okay, you ready? 1, 2, 3. See, and now you know them all so much better. Okay, so first question.
Please clap.
All right, so I have a question from Daryl. How small do you think the bundles will eventually be? And what do you say to people who think Angular is a heavy framework?
I say phooey is what I say to that. I think that it's a thing that we will continually improve. One of the great things about having Angular and having this compiler in the middle is that our goal is that you should be able to write idiomatic Angular components. And as we do better things, as the web gets better, as new things come onto the platform that we can take advantage of, your code will get smaller and smaller and smaller. I think I'd probably get in trouble if I gave an exact number. I'm looking at Stephen Fluen, so I won't do that. But I do think we will get smaller and smaller and smaller over time. It's a thing we will continually improve.
Negative size is our goal.
Yeah, the chart shows will be negative in 2019, I think that was.
Something
so
like
at some point.
It's a goal. It's not necessarily,
Yeah.
Okay, thank you. What's the best way to get...
Stephen? Sure. So we've really worked very, very hard to make sure that the core concepts in Angular aren't changing that fast at all. The things that you learned in version 2.0.0 still work in version 4. They still work in version 5. They're going to keep working in version 6 and 7. Ooh, scary. And so really, the knowledge that you learn when you join kind of the Angular community is going to keep lasting. How to stay up to date. We try to do a really good job of, with every release, putting out a bunch of release notes. We try and make it a little bit more meaningful in terms of blog posts that capture the changes and what they mean for you as a developer. And so I think that's a story that we are doing better at now, and we want to keep doing even better.
Upgrades. You got a mic? Go for it. Oh, I do. Yeah, and also we want to work on tooling that can actually make the process even better and faster and more automatic, so that you guys can actually just do one command, ng update, and that will transform. That will do every baking changes, transform your code, your project, move from one version to the next if there is anything complex, or just make your life easier.
And we should also mention all the educators in our community that are helping people update their knowledge. Shai is nodding his head. So yeah, there's Shai, but there's many other people that are covering. Only Shai. There's only Shai, then nobody else. There are lots of good courses on Pluralsight that are being updated with every major release, so keep an eye on those.
Yeah, basically, for every commit that Mishko does, there's a Reddit post. So if you really want to pay attention at that level, there's a lot of docs on that.
Okay, thank you. Let's see. So one question from Stephen about testing. He's saying, running many tests that use the testbed is slow. Are there any improvements we can expect in version 5 and beyond?
I think I'll take this one. So one of the improvements we made was, with version 5, we shipped incremental AOT compiler, which can help with the speed. We know that there are some more things we can do with the testbed, and these are going to be worked on in 6 and 7.
Cool. My boss keeps pushing me to use Angular with JavaScript instead of TypeScript because he doesn't trust it. But I like it. What can I do to persuade him?
Don't trust your boss.
Well, as another answer, I actually had to do this and convince our boss that it's okay to use TypeScript. So what we won with this is TypeScript becomes JavaScript. So if it really goes terribly, terribly wrong, we can copy the JavaScript output and submit that instead. And so that convinced him that this is still safe. It's still stuff that makes sense to us.
Say what you work on.
Oh, I work on actually Google Analytics, and so I'm up here with the Angular team. But it's a very large project across, I think, 8 different binaries. So we use TypeScript now. Yes. I also contribute to Angular material. So we had the talk on the data table yesterday and some more with AngularJS or AngularJS material a few years ago.
Oh, thank you. What are the pros and cons of migrating a version 1 app to rebuilding from scratch in version 5?
Oh dear.
Did I read that in a
Do I have like
way?
30 minutes just to answer this one?
Sure. Go ahead.
So the short story is that it all comes down to your business drivers. You know, how big your team is, what the benefits of actually using Angular over AngularJS are. There was a really interesting point made by Victor in one of the Q&As where he said that it might be that you don't actually need to upgrade all of your app anyway, that some parts of your app can just stay as AngularJS, because if you make a really nice AngularJS app, it's just great. So why bother upgrading? But the downside of doing the upgrade is that you have to put time in. So you have to be able to balance that out against your business benefits, which are improvements in performance, the fact that the code base is being continually improved, whereas the AngularJS code base is starting to slow down. So I think it's an impossible question to answer generically. It depends on your individual scenario. Anyone else?
The Angular core GitHub repo has 2,000 issues and 300 pull requests dating back 2 years. How can community help with housekeeping?
So actually, just before AngularConnect, I sent out some emails to the team, and we spin up some efforts to get the issue tracker and the pull requests under control. We're working on bringing some robots to help us and
zombies.
Zombies. Robots that will close all the issues. No, we're not going to close all the issues. We've done that once on AngularJS, and it was not a good idea. So we're not going to repeat that mistake again. It just comes down to prioritizing this, and we haven't been in the past, and I think we're changing the approach to this now.
And how can the community help?
The community can help by filing issues that are very clear, so that when we look at an issue, we don't need to be spending hours trying to understand what the reporter is trying to tell us. Because we think every issue is important, but not every issue is understandable and actionable. So if you're filing issues, please make them actionable so that we know what's going on and what we need to do about
it. I was looking out in the audience to see where Manu Murthy is. Is he here? Oh, he flew home. So unfortunately, he flew home, which I just found out. But we also just hired a gentleman named Manu who was here with us for the last 2 days. And one of the first projects he's been working on is actually issue triage. So we made that his priority for a brand new employee. He's also going to help us with our milestone and project tracking for our versions as we move forward, so that we'll have better capabilities to know what we're doing across all of our projects as well.
Nice, thank you. How do you know which versions of Angular, CLI, RxJS, TypeScript, etc. work together? So I guess it's like dependency conflict.
What are you looking at? Well, the CLI actually has some version checking that will tell you whether like your environment is compatible. It's just a warning, but it will tell you like, oh, you're using an old version of TypeScript, maybe you should upgrade, or you're using a version of TypeScript that is not yet tested properly with Angular, so maybe you need to use another version. Outside of that, just when NPM tells you that there is a peer dependency that's not met, or that there is an error in the dependencies, take a look.
Yeah, we usually communicate the version compatibility through the package.json metadata within package.json. So if npm or yarn is telling you that you have a version mismatch in your application, then you should be paying attention to that. Yeah, that's.
Yeah,
We test various versions together, especially in CLI. So multiple versions are supported, and the ones that are not, you'll know through NPM.
Exactly.
I would say historically we were a little bit looser with the version of RxJS or the version of TypeScript that you needed, but specifically in version 5 we had stronger requirements for what you needed because we were relying on kind of more modern versions of RxJS. And so as we're kind of increasing our selectiveness about what versions of TypeScript we support, what versions of RxJS we support, we're going to be adding more tooling to help fill that gap.
Cool. So we're now on to a panel question. So this is for every one of you. We'll pass around the mics. What's the thing you're most excited about for Angular in 2018? Keep it short, please.
Elements.
Start with Pete.
I was going to say that. We were all going to say NG Elements.
That's okay. You can all say that.
We're all done.
I'll say it.
All together now.
Are you all going to say it? Come on, there must be some other answers.
Yeah,
so I was watching the presentation that Lucas gave on animations, and I think making applications that are highly interactive, that are immersive, is very important for the next generation of applications that will come on the web. And I would like Angular to be one of the solutions for this. So I think that would be really cool if we made good progress in this area.
Cool. Anyone else?
I would like to see schematics really taking off and people really making great schematics to use cases, workflows that we didn't think about, and that we can integrate better with the CLI and other toolings. Really looking for the community for that.
Faster, smaller, better and smarter builds. That's what I want.
I'm really excited for service workers in 2018 and what they're going to do for all you guys and girls.
Nobody actually said it, so I'll say elements. No. No, actually, NG upgrade is the thing that I'm most looking forward to. And that will actually also, or should also, solve the problem of version compatibilities as well. As we upgrade your application to different versions, we could also do the same thing with dependencies and matching the dependencies that you need within your application to support a different version. That one and library support. I know a lot of you struggle with publishing separate libraries. To be able to get support for that is going to be a big win for us. Update, upgrade.
No, upgrade is Java, AngularJS.
I'm really excited.
Update, NG update, that's what I said. Can you edit the video, please?
I'm really excited to see, as you guys know, part of my job is kind of talking to other developers that are building with Angular. I'm excited to see the cool stories. We've hit a real critical mass of there's lots of really big companies doing cool things with Angular, but we want to see what other cooler things can you do. So if you have a cool story, let me know.
Kind of following on from that, I'm quite interested to see what people start doing with the CDK. Yeah, as some of the communities start to actually build some really cool widget libraries on top of that.
Sorry, CDK again.
Oh, I thought you'd already decided not to say anything.
Well, since I'm working on IAT, and I would say code translation, a lot of people are waiting for that. So,
anyone else?
Sure.
Okay. I guess for Angular to keep getting smaller and faster, and we have a lot of exciting plans surrounding that for next year. I don't think I can say more than that.
All right, I have another one for which you have to pass the microphone around. What inspires you outside of work?
Okay, I got it. What inspires me? I actually have a near 20-year-old son in computer science, and he sent me an email a few days ago that told me his greatest aspiration is to be like me. So it's pretty inspiring.
How can any of us answer after that?
We're all tearing up.
Anyone else?
Nature, sunsets, sunrises.
And beaches. If I go with the same one, beaches and the waves and all the sounds. I like the sound of the waves. I don't know.
We're deep people.
You guys. I mean, the whole community. The fact that sometimes once in a blue moon, there is an issue where somebody is not negative about a project but says, good job, guys. That's what keeps me going.
So how about we give back to Hans and then everybody goes schematics at the same time. So 1, 2, 3.
Schematic.
Woo!
She got it.
I have to say, actually, I was really inspired this conference by Svetlana, who came and gave an amazing talk with her interpreter. The things that she must have overcome to actually get to where she is in her career is fantastic, and I think that's really inspiring, and that it's very humbling. You know, we've had a much easier ride, I guess. So I'd love to see more of that kind of thing in conferences.
Sorry, just one. For my part, what I like is really see what you people write about Angular. And it always amazes me to see articles on stuff that I do for you. So keep doing community stuff and building new libraries and tools and everything that everyone can use. This is what keeps me going.
For me, it's kind of related to what Hans said. It's when I see, Angular community members just helping each other, and it really warms my heart, because sometimes it's something that I was gonna say. It's like, it's much better that everyone else is saying it and just helping each other and being really positive, because sometimes it's really easy to get frustrated with problems, but that outside voice that tells you, I've been through this, you can do this, and it's really easy. And just seeing people do that to each other, it's really great.
I'll go next. So I'm really inspired by kind of changes and improvements to overall human productivity. I feel like that's a really big factor for kind of the quality of life for everyone across the globe. And so a lot of times when we're building software, it feels like we're treading water, where we're building the same things over and over. But if you just kind of look in the aggregate, compared 10 years ago to today, I can build a web application with real-time data for hundreds of users in 10 minutes. I couldn't do that 10 years ago.
Yeah, you couldn't do that.
Okay. Up next. What is the current state of the estimated lifetime of AngularJS? What can I say?
So if I got it right from the keynote yesterday, Angular.io now has almost 1 million, probably by today. It's over 1 million individual unique users per month hitting it. And the last time I heard, AngularJS was on about 850, 860. So we've now reached that moment where the Angular community is larger than the AngularJS community. And this is something that Brad has said for like a couple of years now, that this was going to be the tipping point where we have to start making a decision about where AngularJS is going to go. And we do have a plan in place, which we're going to start talking about over the next few weeks, about what we intend to do with AngularJS going forward.
So I'll caveat that a tiny bit.
But I'm not sure how much I'm allowed to say.
So there are still millions of AngularJS developers. And we know that, and we care about those people. A lot of those people work at Google. And so AngularJS is not, I wouldn't say ever, I don't think it's ever going to go away. It's just, I think what support means, what the investment means is going to change over time. So if you are building an AngularJS application, it's still going to work next year.
What's that? And longer, right? Longer than a year? Yeah. Go ahead.
And longer?
All right. Do you have any recommended strategies for keeping versions of Angular consistent across production application over time? So version 4, version 4.2, version 5, etc. Should I repeat that?
I'm not sure what that means. What does it mean?
We should ask Chris too.
So I think there's a couple things at play there. So if you have a bunch of teams that have different versions of Angular, there's probably reasons for that, right? Like the teams aren't using the same version control system, they're not using the same CI system, they're not in a mono repo. So we would have to look at kind of each of the challenges of why they can't update. And so it would be really case by case. But I mean, in general, we're designing Angular so that if some of your teams are on version 2 still, it should be relatively straightforward in a reasonable amount of time to get to 4 and then on to 5 and then stay up to date with everyone else. We care a lot about making it easy to stay on the latest version.
Cool. Performance for Angular apps across browsers are not the same. What's your advice on that, especially with infinite pagination?
Andrew?
Dun, dun.
So testing and benchmarking and profiling is a big part of that. Writing infinite scrolls is a good start to that, right? Don't render too many DOM nodes. That's the basic idea, right? But really just being aware of where you're doing things. And I don't know who said this today, but somebody made a point to mention that if when you start development, just go into your DevTools and turn on mobile emulation, right? And work in that mode sometimes. And that, if you can work in that mode and your app is fast in, 5x slowdown mode, then you shouldn't have to worry about any other browser. Your problem comes when you only develop in the latest version of Chrome for 6 weeks, right? And then you don't actually go back and check in other browsers. So testing early, making sure that you're validating that on slower, lower power devices, your app works, and if it doesn't, you have to adjust. But that becomes much more difficult if you're 6, 12 weeks down your development process, right? So you should be testing that on every commit into master. You should know what changed, how fast it is, et cetera.
Right. A question about Angular elements. What about bundling? For instance, I use 3 elements developed with Angular version 2, 4, and 5 respectively. Now I have 3 Angulars on one page without even being aware of that. Any early concepts how to approach that?
So on my slides of things we had to solve, that's one of the things that's listed is how do we do distribution, how do we do deployment, how do we do, sort of over the long term. It's not going to work in 2 or 4, so you don't have to worry about that because it's going to not land in 2 or 4. But in general, I think that one of the things that we'd like to get to is that, the version difference between 5 and 6 and 6 and 7 is going to be so minor that if there is a need to do that, and again, we would hope that that's not the way you do things, right? We would hope that you just keep on the latest version. The idea should always be you can recompile, use the latest version, and that should be trivial to do. But if it becomes that's not a possible thing, right, we have talked about the ability to shim the version between 5 and 6, right? So you use 5 and then you can shim it to 6, or you use 6 and you can kind of shim it back to 5. But in practice, we don't expect this to be much of a problem. Bundling in general is a little bit of a nightmare, and that's a problem that I think the whole ecosystem has. I don't think it's unique to Elements or anything like that. But again, it just comes down to sort of sticking to the latest version and making it as trivial as possible to move between those versions.
Okay, so we're nearly out of time, but I thought I'd end with a really interesting one here. What causes expression change after it has been checked errors? And what patterns can be used to prevent it? I hope you got that. Should I say it again?
Is that part of the ANG game show?
Expression change after it has been checked errors.
So what it means, if you haven't seen this error before, when you're in developer mode, dev mode in Angular, what we do is we run change detection, and then we immediately run change detection again to verify that change detection hasn't caused any side effects, that you're not doing things out of Angular's change detection cycle. Typically, it means you're violating this one-way data flow idea, right? You're doing something that's kind of outside of Angular's loop. And so that's why the error occurs. And the short answer is don't violate one-way data flow, right? But in a lot of cases, there are cases where you can get confused. There are a lot of cases where it's not that simple. I think probably the material team, and maybe Kara has dealt with this on forums a little bit. You could maybe speak to that. But in general, it happens because we're trying to protect you, right? We're trying to expose to you, you are doing something wrong, and it should be an indicator to you that maybe actually I'm not looking at this the right way. It's not so much an error in Angular as much as it's an error in your code, and we're trying to point that out to you so you can fix it before it goes to production.
Yeah, I'll just add on to that. It is actually indicating a real error. It means that if you ran this application in production, something changed after change detection ran, and it's not going to run again in production, so you will not see your UI update and won't pick up that change.
I guess the reason why this sometimes occurs is that in AngularJS, it's very common to do things in watches, like have side effects in watches which affect things other than just what's in the template. So if you used to doing that in AngularJS and you kind of naturally fall over into doing it in change detection in Angular, then we're trying to change your ways.
Great. Well, that's all we have time for, unfortunately. So let's hear it for the Angular team, and thank you very much. Okay, Naomi, Ed.
Do we stay?
Can we have some of your microphones, please? No, you can stay where you are. We like looking at you.
But we're going to take away your microphones. Now we're going to talk about you. I joke. Does someone have a clicker also? Oh, Josh, you've got the clicker.
We're good.
I feel like all crowded. I'm going to go stand on the other side. I don't like hiding behind the podium. What? No, I'm just going. I'm not. I'm really not coming to mock you. Everybody's afraid of me. So, more tweets. Do we have more tweets to celebrate as we wrap things up?
Yes, I think we do.
Aha. Spazimir. Is Spazimir here? Is this somebody who's here on the live stream? No, we're going to celebrate this awesome tweet anyways. So much brain power, a zombie would have a field day at AngularConnect. NG community gets larger and more diverse every year. Thanks to everyone involved. Kudos to Google devs and AngularConnect. Look at all the happy people in that picture. That's lovely. Aww. My 3-year-old taking notes on advanced Angular forms, streamed live by Kara for the win at AngularConnect 2017. He'll be ready for, wait, no, go back. I want to guess on the small child. This one moves me because I left my own small child at home. Tim, if you're listening to the live stream or if somebody knows Tim, could you get him to get in touch with us? Maybe we can send, if it is possible. I learned last year international shipping is hard. So it may not be possible, but if it's possible, we would love to send a child's t-shirt to the adorable 3-year-old who is watching the live stream. Does anybody here have a child who fits into, what size do we go up to? 7 to 8? Show of hands, who here has a size 7 to 8 child? All right. We don't have enough for everybody, but we're going to run a couple out. Size 7 to 8 child. 3 to 4s? Okay, 3 to 4, make your hand like a fist. So I have a system. Maybe a fist is too rude. I don't know. We start getting political. I don't know. Just catch it from Ruth. Do we have any smaller ones? Children's shirts? 3 to 4. Over this side. Run some 3 to 4s over here. And keep one for the adorable child in the tweet. We have another one, right? Okay, next tweet. Abby, is Abby here? Oh, we can't tell. Everybody's putting their hands up. Abby, if you are here, the whole prize thing is falling apart. Ed? Is Abby here?
Yeah.
Wave both of your hands. Yay! Do we have a prize? Hooray. Abby says, suddenly realized I'm not the only one taking notes. I'm the only one taking notes on my notepad whilst everyone else uses their laptop or phone. Look how beautifully analog that is. Taki says, ready for another great day at the AngularConnect selfie contest. Are you still here? Yay! You need permission to view this video. There's a cat video.
This is the best one.
Request access.
Can you describe it? It's a cat playing with a spinner?
Yeah.
Aww.
It's a video with a cat in it. It was always going to win.
Is Joanna here? Joanna? No. Gone home to feed the cat, I suspect.
And that's it.
What? Oh, we need another prize? You don't. Not him. How about a prize for? How about the person who has traveled here by a flight longer than 10 hours? Show of hands. Flight longer than 10 hours to get here. Stand up. Okay, stand up if you flew or took a train or some other mode of transportation more than 10 hours of travel to get here. Stand up. Stand up so we can see. Whoa. Oh yeah, where did you come from? They don't have microphones. From far.
He was wearing a 2015 t-shirt earlier.
There was someone here who was wearing what, an AngularConnect 2015 shirt. Who are you, mystery AngularConnect 2015 shirt wearer? It could be anyone.
He's wearing it today.
Today. Too bad. Gone home. What else?
Okay, I think it's time for us to say thank you.
Yes, it is time. We should say thank you.
It's time to say thank you. So I'm going to reel off a whole load of thanks, but I would like you all to clap and applaud throughout it all, and I'll say it quickly, and we can be out of here. Okay, so let's do that. So let's start the applause. Let's go. So thank you to our amazing sponsors. Thank you to our spectacular speakers. Thank you to the team at Excel. Thank you to Norma and Andrew at White Coat Captioning. Thank you to Dan and his film teaming, streaming. Thank you to our amazing guest hosts, Carmen, Naomi, Joe, and Tracy. Thank you very much to our charity partner, Macmillan. Thank you very much to White October events that make it all possible. And most importantly, thank you to you all for coming. Thank you. Goodbye. No, next year.